Assalamu alaikum warahmatullahi wabarakatuh. Yes, we studied up to the borax bit test in the last class. I'm explaining you 13 group elements. In that 13 group elements, I was completed two questions. Which are those? First one, what is the borax bit test? Okay, now next, Lewis acidic nature of the AlCl3 and BF3. And another important question is left in this 13th group, that is 30 group elements. What is that question? Write the preparation and properties of the structure of diborane. That means in today's class I am going to explain about in detail about the diborane, that is B2H6. Okay, boron hydrides are called as boranes. So this is the diborane and example for the electron deficient compound. This is the example for the electron deficient compound. First we will see how this diborane is prepared. Diborane के preparation के बारे में पढ़ना है. Okay, I am explaining you. I am writing here two simple preparation methods. First one, when boron trichloride, okay, I am taking this one, 2BCl3, boron trichloride is subjected to electric discharge with the H2. BCl3 and H2, when these are subjected to the electric discharge, very simple reaction takes place. And here I am writing this one, silent electric discharge. Okay, electric tube में लेके इन दो gases को pass कर लेके discharge करती है, electric discharge होता है. As a result of that, you will get this compound. That is what? What is our compound? That is the diborane is formed. Okay, so this is the reaction, and remaining are the 6HCl. This is the first preparation method. When BCl3 or BF3 are mixed with the hydrogen and subjected, when these two gases are subjected to silent electric discharge, diborane is formed, B2H6 is formed. This is the one preparation method. Now next, second preparation method, boron trichloride or trifluoride is subjected to what? Is reduced with the lithium aluminum hydride. When it is reduced with the lithium aluminum hydride, I am taking this one. What is that? That is the BCl3, boron trichloride. I am taking once again boron trichloride, and it is reduced with the lithium aluminum hydride. Lithium aluminum hydride. Okay, lithium aluminum hydride, BCl LiAlH4, LiAlH4. To take the 4 moles of this and 3 moles of this as a result of this. Okay, and BCl3 is treated with the LiAlH4, lithium aluminum hydride. Upon the reduction of the BCl3, you see diborane 2B2H6 form हो जाता है, diborane form हो गया यहाँ. The remaining is 3 LiF. यहाँ पे अगर F नहीं रहा तो ये LiCl आ गया, ये LiCl. और नेक्स्ट फिर उसके बाद में 3 एल्यूमिनियम से AlCl3 फॉर्म होता. दिस इज द रिएक्शन. ये दो रिएक्शन से याद रखिए भाई diborane के प्रिपरेशन में. When BCl3 and H2, these two gases are mixed well and subjected to silent electric discharge. When electric discharge is passed through these gases, BCl3 and H2, diborane is formed. This is the one preparation method. And the second one, when BCl3 is reduced with the lithium aluminum hydride, diborane is formed. These are the two preparation methods. These two are enough बेटा. ये दो preparation methods याद रख लीजिए आप. ये reactions हैं उनके. यहाँ पे देखिए 2BCl3 6H2 लेना है, B2H6 plus HCl, 4BCl3 3LiAlH4, 2B2H6 diborane form हुआ, and the 3LiCl and 3AlCl3. These are the two preparation methods, and other preparation methods are also there. These two are enough. ये दो याद रख लीजिए, बस हो जाता है. ये दो preparation methods diborane के. Next, structure of the diborane, फिर उसके बाद chemical properties of diborane. Structure of diborane समझा रहे हैं. Structure of diborane. Structure of diborane ये important है बेटा, एग्जाम में आ सकता. So spectral study shows that, you know what is the molecular formula of the diborane. B2H6 is the molecular formula of the diborane and it is the electron deficient compound. First sentence लिखना, diborane is electron deficient compound, deficient compound, deficient compound. ठीक है ना? देखिए, it not resembles with the structure of ethane. It not resembles with the structure of what? Ethane. देखिए अब ethane मैं ऐसा लिख रहा हूँ भाई, ये ethane है, तीन हाइड्रोजन है क्योंकि कार्बन के लास्ट शेल में देखिए सफिशिएंट नंबर ऑफ इलेक्ट्रॉन्स है, ये 4 कोवेलेंट बॉन्ड्स फॉर्म कर सकता, ये बॉन्ड आ रहा है यहाँ पे। ओके, नेक्स्ट डाइबोरेन के अंदर देखिए बेटा, ये जो 7th बॉन्ड फॉर्म हो रहा ना, ये फॉर्म होने के लिए आपको इलेक्ट्रॉन सफिशिएंट नहीं है, ये BH है, ये BH है, ये ऐसा और एक ये, अगर मैं ऐसा डाल लिया तो देयर इज ए नो इलेक्ट्रॉन टू फॉर्म दिस 7th बॉन्ड, तो इसीलिए इसको क्या बोल के बुलाते हैं? इलेक्ट्रॉन डेफिशिएंट है, इट डज नॉट रिसेम्बल्स विद द स्ट्रक्चर ऑफ व्हाट? ईथेन। ओके, इट इज शॉर्ट इन इलेक्ट्रॉन टू फॉर्म द 7th बॉन्ड लाइक इन ईथेन। ईथेन में जो बॉन्ड्स है भाई, इतने बॉन्ड्स है, इतने बॉन्ड्स फॉर्म हो सकते हैं, मगर डाइबोरेन के अंदर ए बॉन्ड फॉर्म करने के लिए यहाँ पे इलेक्ट्रॉन्स कम पड़ रहे हैं, इसीलिए इसको क्या बोल के बुला रहे हैं? इलेक्ट्रॉन डेफिशिएंट कंपाउंड है। ओवरऑल अब क्या लिखते हैं भाई? एक्सप्लेनेशन दिया, मैं सब लिखने की जरूरत है। हाउ टू राइट लाइक दिस? इट इज द इलेक्ट्रॉन डेफिशिएंट कंपाउंड, इट नॉट रिसेम्बल्स विद द स्ट्रक्चर ऑफ ईथेन, it is short in electron to form the 7th bond like in ethane। 1 2 3 4 5 6, ये 7th bond, ये 7th bond फॉर्म होने के वास्ते यहाँ पे इलेक्ट्रॉन से नहीं है बोल के लिखिए, वो स्ट्रक्चर ड्रा करे तो कर सकते आप, नहीं करे तो भी चलता। सो दिस इज अबाउट द इंट्रोडक्शन। नाउ नेक्स्ट, NMR spectra and other spectral studies shows that among the 6 hydrogens, 2 hydrogens, फर्स्ट ये लिखिए भाई, डाइबोरेन इज द प्लेनर मॉलिक्यूल। NMR spectral study shows that diborane is the planar molecule among 6 hydrogens. 4 belongs to one group and 4 belongs to one group and 2 belongs to other group। B2H6 में 4 हाइड्रोजन एक ग्रुप के हैं, उनको क्या बोल के बुलाना? टर्मिनल हाइड्रोजन्स बोल के बुलाना। एंड 2 रिमेनिंग जो हाइड्रोजन्स है, तो बाकी के जो हाइड्रोजन्स बच गए उनको ब्रिडजिंग हाइड्रोजन्स बोल के बुलाते हैं। एंड दिस BH2 groups are present in one plane and this bridging hydrogens are present one above the plane and second one below the plane। This is about the spectral study। स्पेक्ट्रल स्टडी के अंदर डाइबोरेन कैसा है बल्कि बता रहा भाई, प्लानर, एक प्लेन में है। कहते कौन कौन एक प्लेन में है? BH2 ग्रुप्स, 2 BH2 ग्रुप्स एक प्लेन में और एक हाइड्रोजन अबव द प्लेन है और एक हाइड्रोजन बिलो द प्लेन है, ये प्लेनर मॉलिक्यूल है। दिस इज अबाउट द जनरल इंफॉर्मेशन रिगार्डिंग टू द स्ट्रक्चर ऑफ द डाइबोरेन। Once again I am repeating, diborane is the electron deficient compound, it does not resembles with the structure of ethane, it is short in electrons to form the 7th bond like in ethane। Spectral study shows that diborane is the planar molecule and among the 6 hydrogens in the diborane, 4 belongs to one group called as terminal hydrogens and 2 belongs to other group, that those 2 hydrogens are called as bridging hydrogens। Now you have to draw this structure। 2 BH2 groups are present in one plane। Now next, one hydrogen is present above the plane and other hydrogen is present below the plane। This is the general structure। Now next I am explaining you about the orbital structure of the diborane। Orbital structure of the diborane, orbital structure of the diborane। So you have to see this, what is the atomic number of the boron 5, electron configuration 1s2, 2s2, 2p1 is the configuration। Okay, this is the 2s2 configuration, 2p1 configuration। excited state है भाई, excited state में एक इलेक्ट्रॉन 2s1 2p2 हो गया, ये 2s1 है और ये 2p2 हो गया। It undergoes which hybridization? sp3 hybridization। In the diborane, boron undergoes sp3 hybridization. As a result of this sp3 hybridization on the boron, how many hybrid orbitals are formed? 4 hybrid orbitals are formed. They are arranged in this manner like this. I say 4 hybrid orbitals डाल ले रहा हूँ मैं. So among them 3 are contains electrons. तीनों में electrons है. One is vacant. एक vacant है. Same diborane में 2 boron रहने से I am drawing once again that like that structure only. देखिए वैसी structure उतार रहा हूँ मैं ये 4 hybrid orbitals of the other boron, in which 3 contains the electrons like this and 1 is the vacant orbital is there. Now then this hybrid orbital overlaps with the hydrogen atom and this one is also overlap with the hydrogen. ये hydrogen है. और this one is also overlap with the hydrogen and this one is also overlap with the hydrogen. ऐसा ये terminal hydrogens एक type के hydrogens हो गई है. Now then one hydrogen is overlapped with the क्या होता भाई ये vacant boron के vacant orbital और एक single electron वाले orbital से overlap करते हुए यहाँ से यहाँ तक ये overlapping extend होता. As a result of that you will get the one special type of the bond. One hydrogen overlaps, that is the one hybrid orbital of the boron in which one electron is present is overlaps with the hydrogen orbital and also overlaps with the vacant orbital of the other boron. As a result of that a special type of the bond is formed that look like the banana. It is called as the banana bond or also called as the tau bond. And you know that how many centers are there in this bond? 1, 2, 3 centers are there and only 2 electrons are there. It is called as 3-centered 2 electron bond. Okay, so such type of the other bond is also formed below this. यहाँ पे और एक 3-centered 2 electron bond हो रहा. कैसा आ रहा है? देखिए, one hybrid orbital of the one boron overlaps with the hydrogen atom and also overlaps with the another vacant orbital of the other diborane, vacant orbital of the diborane. As a result of that 3-centered 2 electron banana or tau bond is formed. So such there are 3-centered 2 electrons are present in this diborane. तो orbital structure में क्या करना है? In the diborane boron undergoes sp3 hybridization. As a result 4 hybrid orbitals are there. Among them 3 electrons are there. One is vacant and I am drawing the other boron. So this is the 4 hybrid orbitals of the other boron. In that also 4 hybrid orbitals are there. Among them 3 contains the electron and 1 is the vacant. So the terminal orbitals, these are the orbitals overlaps with the hydrogen. So as a result of that BH2 units are formed, 2 BH2 units are formed. तो ये BH2 units के हो गया तो फिर उसके बाद में one hybrid orbital which contains the electron overlaps with the hydrogen atom and also overlaps with the vacant orbital of the other boron. As a result of that 3-centered 2 electron bond is formed, that is called as a banana or tau bond. Okay, so below the plane also यहाँ पे भी नीचे से एक 3-centered 2 electron bond form होता. Such 3-centered 2 electrons are 3-centered 2 electron bonds are formed in this diborane. So this is about the structure of the diborane. A diborane का structure है. Now next, what are the properties of the diborane? Chemical properties है. Diborane एक gas है. तो physical properties छोड़ दो. Chemical properties of the diborane. Chemically कैसा behave कर रहा? First वाला reaction of the diborane with the water. कैसा react हो रहा diborane? Water से कैसा react हो रहा? I'm going to explain that one. Okay, how it reacts with the water. See that what is the diborane B2H6? ये diborane है 6H2 hydrolysis होता. Okay, as a result of that what is the product is formed? Okay, B2H6 plus 6H2O. These are the stoichiometric ratio. एज ए रिजल्ट ऑफ दैट क्या फॉर्म होने वाला है मालूम है आपको, H3BO3 बोरिक एसिड फॉर्म होता है, H3BO3 इज फॉर्म, बोरिक एसिड इज फॉर्म। ओके, बैलेंस हो गया ना, दो बोरान से और H3BO3। ओके, नाउ नेक्स्ट remaining is what is formed here, H2 gas is liberated. This is about the reaction of the diborane with the water. Diborane when treated with the water you will get the boric acid, boric acid form hota। This is about the first property what happened when diborane is treated with water। ठीक है भाई, तो second one, when diborane is reacts with the oxygen which is present in the air, हवा से react हुआ तो क्या form होता? Okay, this is the reaction, I am writing this one, B2H6 है diborane, when it is treated with the air, water sorry यहाँ पे air से oxygen से react हो रहा, diborane क्या form होगा भाई, B2H6 की जगह क्या form होता, B2O3 form हो जाता, B2O3 is formed and what is the remaining thing left बेटा, यहाँ पे क्या फॉर्म होता है, यहाँ B2O3 के बाद में 3H2O फॉर्म होता है यहाँ पे। So this is about the reaction of the diborane with the oxygen। When diborane is heated with oxygen, when diborane is heated with the oxygen, it reacts with the oxygen and that forms the B2O3। B2O3 को form करता, boron trioxide, this is formed। Now next about the reaction with the ammonia। रिएक्शन विथ HCl वगैरह है वो ज़्यादा ज़रूरत नहीं है, इतना इम्पोर्टेंट नहीं। और रिएक्शन विथ अमोनिया से एक VSAQ है बेटा, व्हाट इज द पॉसिबल रिएक्शन ऑफ दिस बेटा, आई एम राइटिंग दिस वन, B2H6 diborane when it is treated with the excess of ammonia 6Na3 at high temperature, ज़्यादा टेम्परेचर से अपन गर्म कर लिए तो एज ए रिजल्ट ऑफ दैट यू विल गेट दी this one B3N3H6 is formed, B3N3H6 plus 2H2, this is the reaction when the diborane is heated with the ammonia with a higher temperature, about high temperature, as a result of that you will get the B3N3H6 called as, क्या बोल के बुलाते हैं इसको, what is called, it is called as the borazole or borazine बोल के बुलाते हैं। This in this borazole or borazine, see that this is this compound, देखिए it exactly resembles with the benzene, तीनों जगह पे आप बोरान को डाल लो B एंड तीनों जगहों पे आप नाइट्रोजन को डाल लो, exactly इनके बीच में डबल बॉन्ड जैसा बेंजीन में है वैसे ही डाल लो, बोरान पे एक हाइड्रोजन, नाइट्रोजन पे एक हाइड्रोजन। So this is the structure of the B3N3H6, exactly resembles with the structure of the benzene। बेंजीन के जैसी स्ट्रक्चर है, उसीलिए इसको क्या बोल के बुलाते, इनऑर्गेनिक बेंजीन बोल के बुलाते। व्हाट इज द इनऑर्गेनिक बेंजीन, हाउ इट इज फॉर्म, दैट इज द VSAQ। when diborane is heated with ammonia at high temperature, that is we will get the B3N3H6, that is called as the borazole or borazine। It is known as the inorganic benzene because it exactly resembles with the structure of the benzene। So this is about the structure of the borazole, it is an important VSAQ। ठीक है, तो ये डाइबोरेन के बारे में मैं समझाया। डाइबोरेन के दो प्रिपरेशन मेथड्स, आई वाज एक्सप्लेन टू प्रिपरेशन मेथड्स in this now then structure of the diborane I was explained, after that I've written some chemical properties। chemical properties अगर आए तो इसी में से आते बेटा, तीन chemical properties, that is reaction with water लिखा, reaction with air, reaction with ammonia लिखा। HCl से भी रिएक्शन है, Br2 से भी रिएक्शन है, वो ज्यादा नहीं पूछ रहा, बस इतना काफी हो जाता। सो you have to remember the 3 equations and 2 equations in the preparation, and you have to read the structure, you have to learn the structure of the diborane। Structure of the diborane is important for SAQ। In this chapter 2 important questions are there, first one is the borax bit test and this is the second question, write the any 2 preparation methods and properties of diborane or write the structure of the diborane। these questions I was explained। Then after that some important questions, some questions are left in the organic chemistry, that will complete this syllabus। I was explained all these S group elements, S block elements, in which Some questions are there in a 1A and some important questions are there in the 2A. I was explain all those. Now then after that, in the third A group elements, I was explained the basic Lewis acidic nature of the BCl3 and BF3. So that is the one question. And what is the second important question in that? तो थर्ड ए ग्रुप एलिमेंट्स में और कौन सा क्वेश्चन इंपॉर्टेंट है? थर्ड ए ग्रुप एलिमेंट्स में बोलिए जब से समझा है ना. I was explain the third A group element just now. No. Another important question is borax speed test, and another one is the important two methods of the preparation of diborane and structure of diborane. So these are the important questions in this third A group elements. In the fourth A group elements, which are the questions important? You know this. In the fourth A group elements, what is the catenation? Allotropy. Okay, ये छोटे छोटे definitions पूछता. नहीं तो फिर in the fourth A group डायमंड एंड ग्राफाइट के बारे में, इसके प्रिपरेशन, इसके अंदर इनके स्ट्रक्चर्स और क्या है भाई, इसके अंदर स्ट्रक्चर्स और प्रॉपर्टीज के बारे में पूछता, या नहीं तो फ्लोरीन्स के बारे में पूछता, फ्लोरीन्स, या नहीं तो और एक क्वेश्चन है भाई सिलिकेट्स, सिलिकॉन्स. All this I was explained in last class. Now then VSAQs है, थोड़े VSAQs है. VSAQs, in this VSAQs, what is the water gas एक है, what is the toxic effect of carbon monoxide, what is dry ice किसको बोलते हैं, और ये properties of diamonds में ग्राफाइट में आता बेटा. Why diamond is hot and it is the insulator of electricity. Why graphite is soft? Why graphite is the conductor of electricity? Why graphite is acts as the lubricant कैसा graphite काम करता? What is the reason? इसके बारे में क्वेश्चन ज्यादा आ रहे हैं, यहाँ से क्वेश्चन ज्यादा आ रहा बेटा. तो डायमंड इज हार्ड है. Why diamond is hard means because due to the presence of the single covalent bonds. Why it is insulators means there is no free electrons, all are paired electrons are there, bonded electrons are there. So why graphite is the conductor? Graphite is the conductor because on each carbon one free electron is present in the unhybridized orbital. Due to this mobility of free electron, it acts as the conductor of the electricity. Why it is lubricant? Okay, in this carbon undergoes, in the graphite carbon undergoes sp2 hybridization. As a result of this, three hybrid orbitals are formed. So overlapping of these three hybrid orbitals with the other carbon hybrid orbitals gives hexagonal rings. Okay, these hexagonal rings are arranged in a manner one layer like structure is formed. Okay, between these two layers, weak van der Waals force of attractions are present. Therefore, it is viscous and it acts as a lubricant. It is useful to reduce the friction. So these are the some properties with some VSAQs which are important for your examination. So all these things I was explained. Now then after that I'm explaining you about this important question in the organic chemistry. In this organic chemistry, first SAQ important one is what is the ozonolysis and Friedel-Crafts reaction, alkylation reaction. ये दो रिएक्शंस और एक इसके साथ में पूछा तो वुड्स रिएक्शन, ये रिएक्शंस मिला के पूछ सकता हूँ. नाउ सेकंड क्वेश्चन, व्हाट इज द सेकंड क्वेश्चन इन दिस? राइट अबाउट द पोजीशन and functional group isomerism. Position and functional group isomerism. Positional and functional group isomerism. And the third important is write the following conversion. CsC2 gives rise to, upon the hydrolysis of this, get the A. Okay, of the reaction of A with the what reaction when E is passed to the hot copper or iron tubes, will get the B. Now then, when it is treated with the CH3Cl in presence of AlCl3, get the C. What are ABC? ये रिएक्शन देता आपको, इसमें ये रिएक्शन में ABC क्या है और ये रिएक्शंस कंप्लीट करो बोल के पूछ रहा. ये वेरी इंपॉर्टेंट SAQs है ये तीन. These are the very important questions, most important questions in this organic chemistry. Organic chemistry से LAQs कौन से है भाई? Which are the LAQs है? First one, how benzene is prepared? How benzene is prepared? How benzene is prepared? Write the electrophilic substitution of electrophilic substitution reactions of benzene. Substitution reaction of benzene. And second important LAQ is how acetylene is prepared. How acetylene is prepared. How acetylene is prepared. And write the chemical properties. And chemical properties, those are mentioned in the question paper. तो ये important है. या ये नहीं आया तो how ethylene is prepared. How ethylene is prepared. And write the chemical properties which are mentioned in that question paper. Question paper में देता chemical properties. ये तीन LAQs है ऑर्गेनिक से, इसमें ये मोस्ट इम्पोर्टेंट है. और ये तीन SAQs जो मैं बोर्ड पे लिखा और ये SAQs ज्यादा रिपीट हो रहे हैं एग्जाम में. तो कंप्लीट दिस वन बाय वन. व्हाट इज द ओजोनोलिसिस और फ्रीडल-क्राफ्ट अल्काइलेशन क्या है, वुड्स रिएक्शन क्या है, ये पहले कंप्लीट करेंगे अपन. ठीक है, विल सी वन बाय वन. Ozonolysis means addition reaction of the ozone with the unsaturated hydrocarbon. But the addition of the ozone को ऐसा लिख ले रहा हूँ मैं समझाने के लिए, नहीं तो O3 बोल के लिख ले सकते हैं आप. ओके, but the addition of the ozone, two bonds are required. If there are two bonds are not there, it is impossible to add this ozone on this compound. तो ओजोन को ऐड करना बोले तो डबल बॉन्ड होना, डबल बॉन्ड नहीं रहे तो ओजोन ऐड नहीं होता. वैसे हाइड्रोकार्बन्स के नाम में नहीं जाता, रिएक्शन में पार्टिसिपेट नहीं होता. दैट मीन्स O3 इज यूजफुल फॉर द डिटेक्शन ऑफ द अनसैचुरेशन. डबल या ट्रिपल बॉन्ड कहाँ है, अनसैचुरेशन कहाँ है, आइडेंटिफाई करने के वास्ते ओजोन को यूज करते. ये टोटल प्रोसेस को क्या बोलते, ओजोनोलाइसिस बोल के बुलाते. ओके, असल लिखना क्या है, व्हाट यू हैव टू राइट इन दिस, ओजोन अंडरगोस एडिशन रिएक्शन विद द अनसैचुरेटेड हाइड्रोकार्बन्स and forms the cyclic intermediate. Just I was told you that for the addition of ozone, how many bonds we have to lift? We have to lift two bonds like this. Okay, यहाँ से दो bonds उठा दिया, निकाल दिया. CH2 बाजू बाजू लिख लेके तीन ऑक्सीजन्स को ऐसा डाल दिया. This is called as the intermediate, called as ethylene ozonoid form हो रहा है यहाँ पे. When ethylene reacts with ozone or ozone undergoes addition reaction with unsaturated compound, that is the ethylene, and forms the ethylene ozonoid. Okay, it undergoes hydrolysis in presence of the metal zinc. Okay, ये structure break हो जाता है ऐसा, एक बाजू से एक हिस्सा ये CH2O, इधर से it undergoes hydrolysis and forms this compound 2CH2O. That is, इसको ऐसा भी लिख सकते हैं HCHO बोल के. It is called as what, formaldehyde is formed. Formaldehyde is formed. So this is the reaction. This is the reaction between ozone and unsaturated hydrocarbons. That is called as what, ozonolysis. For example, I am taking this ethylene. Ethylene undergoes addition reaction with ozone and forms ethylene ozonide and forms that undergoes hydrolysis in the presence of zinc and forms the formaldehyde. This reaction of the ozone with unsaturated compound is called as ozonolysis. इसमें कई एग्जाम्पल ले सकते हैं आप, एक इथलीन ले सकते हैं या नहीं तो फिर एसिटिलीन ले सकते हैं, CH ट्रिपल बॉन्ड CH प्लस O3. तो यहाँ पे क्या आने वाला है, दो बॉन्ड्स निकाल देना, एक बॉन्ड को रखना लाइक दिस, और ओजोन के तीन ऑक्सीजन एटम्स को ऐसा लिख लेना. ओके, आई एम राइटिंग द 3 ऑक्सीजन एटम्स ऑफ ओजोन लाइक दिस. ओके, इट अंडरगोस hydrolysis in presence of the zinc. In presence of the zinc, hydrolysis of this takes place. Okay, यहाँ से ऐसा ये ब्रेक हो गया तो CHO आ गया, सिंगल बॉन्ड बाई C है CHO. तो इसको क्या बोलते हैं भाई, ग्लायोक्सॉल बोलते हैं. ग्लायोक्सॉल इज फॉर्म. If I am taking the acetylene, the product is glyoxal, CHO. Whatever it may be, addition reaction of the ozone with the unsaturated hydrocarbon is called as ozonolysis. This is the first reaction, ozonolysis, important one. Then about the alkylation, which alkylation? Friedel-Crafts alkylation. Okay, this reaction I was explained in the properties of benzene also. See here, once again I am taking this one benzene only. Okay, benzene when treated with what? Alkyl halide. Okay, Friedel-Crafts alkylation. Friedel-Crafts alkylation. Alkylation means what? We are substituting the alkyl group. For this, what is the reagent we are using for the alkylation purpose? CH3Cl, alkyl halide. Alkyl halide in the presence of the Lewis acid, AlCl3. When benzene is treated with the alkyl halides in the presence of AlCl3, तो रिएक्शन ऐसा होता H ये Cl से चले गया CH3 is substituted on this, you will get the alkyl benzene. This is the reaction is called as the Friedel-Crafts alkylation reaction. Friedel-Crafts alkylation reaction है ये. Now then after this what is the position and functional? Before going to that, what is the Woods reaction? ये भी थोड़े reactions है देखेंगे. Woods reaction क्या है और Sabatier Sanderson reduction क्या है ये भी देखेंगे. Sabatier Sanderson reduction. What is the Woods reaction? Heating of the alkyl halides. CH3Cl है. It is heated with the sodium metal. Once again I am taking this CH3. Two molecules I am taking. Two molecules of alkyl halides when heated with the sodium metal. From the lower alkyl halides से higher alkyl halide form होता. CH3 combines with the CH3, C2H6. ये Na और Cl मिल गया, 2 NaCl चले जाता. So as a result of that you will get the ethane. When methyl chloride, two molecules of methyl chloride is heated with sodium metal in presence of the dry ether solvent, ethane is formed. This reaction of alkyl halide heating with the sodium metal is called as Woods reaction. What is the Sabatier-Sanderson reduction? Sabatier-Sanderson reduction is nothing but the saturation of the unsaturated compounds, either acetylene or ethylene. These are saturated by adding the hydrogenation of oil in the presence of the nickel. This reaction takes place. The nickel is the catalyst is used. Okay, when ethylene is treated with the H2, that is ethylene is reacts with the H2 in the presence of the nickel catalyst. देखिए ये बॉन्ड एक ब्रेक होता है, एक हाइड्रोजन इधर और एक हाइड्रोजन इधर ऐड हो रहा. CH3 सिंगल बॉन्ड CH3 फॉर्म होता, ऑल्केन फॉर्म होता है, यहाँ पे ईथेन है. So this is the reaction is called as Sabatier-Sanderson reduction. When ethylene is treated with the or reacts with the H2 in the presence of the nickel, ethane is formed. It is a reduction called as Sabatier-Sanderson reduction. Okay, after this I am explaining you about the position and functional group isomerism. Position and functional group isomerism. Okay, what is the isomerism? Isomerism किसको बोलते हैं? Simply I am writing one example. पहले ये देख लो आप, functional group में एक example लेके लिख रहा हूँ मैं. CH3Cm. I am taking the another one, CH3Nc. These two are different compounds. But their molecular formula is same. Count how many hydrogens are there, how many carbons are there? 2 carbons. And how many hydrogens are there? 3 hydrogens. And 1 nitrogen is present. Okay, molecular formula is same, but with same molecular formula 2 different compounds are there. This is a phenomena is called as isomerism. Isomerism means compounds with same molecular formula. Different compounds with same molecular formula are called as what? Isomers. Okay, and this phenomena is called as isomerism. Isomerism of various types. Isomerism कई तरीके का है, वो ज़्यादा ज़रूरत नहीं है अपने को. तो यहाँ पे पोजीशन एंड फंक्शनल ग्रुप आइसोमरिज्म दिया, तो इसके बारे में अपन पढ़ लेंगे बस. ओके, व्हाट इज द पोजीशन आइसोमरिज्म? पोजीशन आइसोमरिज्म में देखिए मैं एक कंपाउंड लिखा मैं, तो कार्बन की वैलेंसी कितनी है भाई, देखिए 4 वैलेंसी, 4 बॉन्ड्स हो गए, यहाँ 4 बॉन्ड्स हो गए, यहाँ पे 4 बॉन्ड्स हो गए, यहाँ पे क्या डाला, एक क्लोरीन डाला। इसको क्या बोलते हैं, फर्स्ट कार्बन पे क्लोरीन है तो 1 क्लोरो, 1 क्लोरो, 3 कार्बन रहने से प्रोप और सिंगल बॉन्ड रहने से क्या लिखा, प्रोपेन बोल के लिख रहा हूँ। 1 क्लोरो प्रोपेन इज द नेम ऑफ दिस कंपाउंड। चलिए आई एम राइटिंग द अनदर कंपाउंड। कौन सा अलग और क्या कौन सा कंपाउंड लिख रहा हूँ, जरा देखिए गौर से देखिए, हाइड्रोजन 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 एंड हाइड्रोजन 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 एट हियर Cl. What is the name of this compound? On the second carbon chlorine is there, it is called as the 2-chloro, 2-chloro, 2-chloropropane, 2-chloropropane is the name of this compound. These two are the different compounds but with the same molecular formula. इन दोनों का formula same है. How many carbons are there? 3 carbons are there. How many hydrogens are there? 1, 2, 3, 4, 5, 6, 7. 7 hydrogens are there and 1 chlorine atom is there. So in this compound there are 3 carbon atoms, 7 hydrogen and 1 chlorine is there. So with this formula I am writing the two different compound. One is called 1-chloro and second one is called as 2-chloropropane. Why this become different? Because at here position of the substituent is different. At here chlorine is attached on the first carbon. In the second compound position of the chlorine is on the second carbon. So compounds with same molecular formula but they are differ in the position of the substituent or functional group. This type of the isomerism is called as position isomerism. So what is the position isomerism? ऐसा लिखना है आपको, compounds with the same molecular formula but they are different, but they are different in the position of substituent or functional group. substituent और functional group के position में difference रहे तो that is called as what? Position isomerism. C3H7Cl is the example. With this formula I am writing the two different compounds. One is called as, first one is the 1-chloropropane and second one is known as the 2-chloropropane. और एक भी लिख सकता हूँ, 1-butene है, 2-butene है, दोनों का फॉर्मूला सेम रहता, फंक्शनल ग्रुप का जो पोजीशन है डिफरेंट है. सो दिस इज अबाउट द पोजीशन आइसोमरिज्म. नेक्स्ट अबाउट द फंक्शनल ग्रुप आइसोमरिज्म. functional group isomerism. Functional group isomerism. What is the functional group isomerism? Okay, see that I am writing this one. जब से मैं लिखा सो ले लो, नहीं तो वो सिंपल रहता. See that CH3CN, this is called as methyl cyanide, this is called as methyl isocyanide. These two are different because in this cyanide functional group is there, in this isocyanide functional group is there. So देखिए दोनों का फॉर्मूला सेम है, C2H3N. Okay. Compounds with the same molecular formula, different compounds are compounds with same molecular formula but they are differ in the functional group. Compounds with same molecular formula, same molecular formula but they are different, functional group. Is called as which isomerism? Functional group isomerism. Cyanides, isocyanides are the functional group isomers. Aldehydes and ketones, एक ही फॉर्मूले से aldehyde भी लिख सकते, ketones भी लिख सकते, एक ही फॉर्मूले से अल्कोहल भी लिख सकते, ईथर भी लिख सकते. अल्कोहल से अलग, ईथर से अलग, दोनों में फंक्शनल ग्रुप से अलग है. ऐसे कंपाउंड्स को फंक्शनल ग्रुप आइसोमर्स बोलते हैं. तो ये फिनोमिना को फंक्शनल ग्रुप आइसोमरिज्म बोलते हैं. दिस इज अबाउट द functional group isomerism. Then the next question, conversion. Conversion, this is the last one in this today's class. I'm going to explain this last question, that is the CaC2. CaC2 अपन hydrolysis. CaC2 को hydrolysis करे भाई तो कौन सा प्रोडक्ट आता है? A. तो ये रिएक्शन लिख रहा हूँ, देखो CaC2 प्लस 2H2O ले लो आप, 2H2O. 2H2O का मैं ऐसा लिख रहा हूँ, HOH और HOH ऐसा ले रहा हूँ. C2 को हाइड्रोजन से मिला दिया, कैल्शियम को OH से दे दिया. एज अ रिजल्ट यू विल गेट द C2H2 plus CaOH taken 2. This is called as what? Acetylene. What happened when calcium carbide is subjected to hydrolysis? When water is allowed to react with the CaC2, when water is treated with the CaC2, acetylene is formed, C2H2. When acetylene is passed through the copper or iron tubes, when it is passed through the copper or iron tubes, what happened? Polymerization, trimerization of this takes place. C6H6 benzene is formed. So when A is passed through the copper or iron tubes, what is B? B, that is the benzene is formed. Then when benzene C6H6 is treated with the CH3Cl, when it is treated with the CH3Cl in presence of the AlCl3, what is the product is formed? C6H6. Among this H6, I am removing one hydrogen and writing C6H5 and substituting this CH3 on the benzene. We will get this one, C6H5CH3, methyl benzene is formed. So what is the A product? A is the acetylene and B is what? This is the benzene, and C, that is what? Methyl benzene. These are the names of compounds formed during this reaction. CaC2 when subjected to hydrolysis, acetylene is formed. When acetylene is passed through the copper or iron tubes, benzene is formed. When benzene reacts with the CH3Cl, in presence of the AlCl3, methyl benzene is formed. Okay, the remaining thing I will explain you in next class, inshallah.